Let's start with the first order techniques to learn how to solve first order differential equation. First order differential equation. First method is variable separable. So as the name shows, variable separable means, if possible, to collect all x term with dx and all y term with dy, then integration will give you the solution. For example, so if possible to collect all x terms with dx and all y terms with dy. That is, if you are like writing like this, dx plus f of y dy equal to 0. This you have bringing all x term with dx and all y term with dy something equal to 0, then integration will give you the solution. That is, if you integrate fx dx plus integrate fy dy, so there is a constant of integration. Since we are solving first order differential equation, so there must be a constant of integration. So let's have example. Solve the following differential equation. I am writing couple of differential equation, and if possible you are solving x with, so if you are writing in this way, then integration will give you the solution. Question number 1 is dy by dx plus 2xy equal to 0. This is the question number 1. So you can solve solution. You can write dy by dx is equal to minus 2xy. Let you are bringing y with dy. So 1 over y dy is minus 2x dx. Look, you have separated variable. All x term with dx and y term with dy. Then integration. So this is ln y is equal to minus 2 x square divided by 2 plus c. And let you have c on the x side, on the right hand side. So 2 goes, this is ln y is equal to minus x square plus c. So this is the answer of a differential equation which is first order and linear as well. So let me have couple of more. So dy by dx plus 2xy square equal to 0. Third one, dy by dx is equal to 64 xy raised to the power 1 by 3. Then dy by dx is equal to 2x secant y. Then fifth is 1 minus x square. Dy by dx is equal to 2y. Sixth is 1 plus x square. 1 plus x square is outside here. Dy by dx is equal to 1 plus y whole square. 6th and 7th. Y cube dy by dx is equal to y4 plus 1 cos x. Then 8th, dy by dx is equal to x minus 1 y raised to the power 5 over x square 2y cube minus y. Then ninth is x square plus 1 dy by dx is equal to x. And the 10th is x square plus 1 tan y dy by dx is equal to x. So these are the question in which you are solving, finding the solution by looking at the question, how to find the solution. For example, this one, the same way you can take minus 2x square xy square and dx with 2x y square is in the denominator you can have. So this question, this you can write 4 raised to the power 3, 1 by 3. 4 cube is 64. And this is x 1 by 3, y 1 by 3. So this 3 goes. So bringing dx with x raised to power 1 by 3, y 1 by 3 is in the denominator and solving, getting the answer. Similarly, you can have 2 y's there, 1 minus x square. Let me have 2 more questions so that you can have. Let me have this, 5th one. dy by dx is equal to 2y over 1 minus x square. So dy over 2y is equal to 1 minus x square into dx. This I have separated. X term with dx and y term with dy. If you are integrating, so this is half is there, natural log y, because the derivative y is dy is there. But here in this case you can have partial fraction. Once you have partial fraction, then you are writing the answer. So let me have the partial fraction. For partial fraction, consider 1 over 1 minus x 1 plus x is equal to 1 over 1 minus x square, a plus b, a minus b. This is a 1 minus x plus b 1 plus x. Multiplying by LCM. This goes 1 is equal to 1 plus x plus b 1 minus x. Since both the factors are linear, both linear factor, you're putting one after the other 0. Put 1 plus x equal to 0, this implies x is equal to minus 1. So if you are putting x is equal to minus 1 here, that vanish. So 1 is equal to minus 2b. X is minus and minus plus 2b. 2b, this implies b is equal to half. If b is equal to half, again put 1 minus x equal to 0, this implies x is equal to 1. X is equal to 1 makes 0 and a is half. So a is half, b is half. So it means I have integration there. This is a over 1 minus x plus b over 1 plus x, and this is dx. I have found the value of a and b. A is half and b is half. Let half is taken out. And integral 1 over 1 minus x plus 1 plus x and dx, both. So here 1 minus x, the derivative is minus dx. So it could be minus 1 by 2 natural log 1 minus x plus 1 by 2 natural log 1 plus x plus a constant of integration, and this is half ln y on the left. Look at that. Minus, if you multiply minus and this minus there, because this half is with this term, both terms having half with it. So this become minus half ln 1 minus x and half is multiplied with it. So half ln this and c. So if you are going to have multiply by something half or something, you can simplify. So multiplying by 2. If you multiplying 2, so let me simplify. so that you can have the answer in simplified form. Multiplied by 2, you are getting natural log y is minus ln 1 minus x plus ln 1 plus x plus c1, because 2 is multiplied with c, so you are getting another constant which is c1. If I am going to have natural log 1 plus x over 1 minus x, this plus c is equal to natural log y, this I can have. So you can cancel the natural log, or you can something with c, some you can write. So you leave the answer there, or if you are taking the anti-log, this become y is 1 plus x over 1 minus x plus c1. So you can have, because e raised to power c1 is something c1. You can have any constant. Natural log is cancelled with bottom, and this c1 is, c is cancelled. So this will be the solution of the differential equation, which is this, because you can have the partial fraction. Similarly, you can separate variable here, here, and this here. Look at that. In ninth question, you are having dy is x over x square plus 1 dx. I have separated variables. If I separated variable and I am going to integrate, there is y on the left. Here the derivative is 2x. Let you multiply and divide by 2, and you can write down the answer. Similarly, you can separate and you can find the answer. Couple of questions which I have left. This is an exercise for you. So there are 10 questions. I have solved couple of. So but the rest of the questions you can solve yourself, and we'll discuss the answer.